Hello, I'm Dr. Ian McCullough, and in this lecture, we're going to be talking about the ROAD, or ROAD framework for managing AI and data science projects. So our learning objectives in this module is to define some of the common vocabulary terms, buzzwords in AI, and the other one is to describe the ROAD framework, which is what we're going to do in this lecture. There is no shortage of management frameworks for managing AI projects or projects in the analytics space or IT space. The first and probably most widely used in educational programs anyway is the CRISP DM. And so this was developed by IBM, and it really focused on understanding business context. So a lot of data projects, people felt that there was not really good communications or understanding between managerial leadership and technical leadership. So they would focus on this understanding the business concept or context. Other elements would be like understanding the data, preparing the data, modeling, evaluation, and deployment. And so this is generally a good guideline because it's bringing this idea that your data is not just sitting there ready to be analyzed. There's stuff you have to do in the modeling. You have to evaluate how well the model is actually working. You got to think about how you're going to scale it. But the most important aspect of CRISP DM, in my opinion, is understanding the business context. Another very common word you'll hear is agile or safe agile. And so this is very popular in software development, and a lot of people, because AI is taught in computer science programs, as is software development, it's very common that people are going to use agile in doing AI projects. And really what agile is doing is it's promoting the idea of iterative development, collaboration, flexibility, and adaptability so that you can develop quickly and stay flexible to shifting or changing client or end user needs. One of the weaknesses in Agile is it doesn't really, it actually does a good job of dealing with the business context, but what it doesn't do is it doesn't really highlight what you need to think about in terms of your data and your models and some of those aspects. Other companies are going to have their own system, right? Like so Microsoft does team data science process. And so they have modified these general concepts and they've focused on this additional aspect of customer acceptance. So it's not just good enough to accomplish a business context. Does the customer actually use and accept and like and engage with the end product? It's also, I think, a much more of a customer-facing development process than it is looking at internal processes for your corporate decision making, for example. Google has the machine learning lifecycle framework. They focus a little bit more on problem framing, and they introduce the idea of monitoring. So this idea that when you put in an AI process based on a set of data, the environment or the context can change over time, and those algorithms can drift and lead to bias in your decision making. So are you monitoring it? The KDD, knowledge discovery and databases, is another term you might hear about. It's focused on discovery of knowledge. It's iterative exploration and modeling. My opinion is that oftentimes shortcuts the scientific process and can lead to, in execution, can lead you to biased results. And it's more about not in the KDD as it's described in its documentation, but when teams start implementing it, the teams tend to use it more to write a report card of how great they are, rather than having objective, honest assessment. Right, so that becomes a problem. One of the more recent ones is FATE, Fairness, Accountability, Transparency, and Ethics, and it's supposed to help people consider ethical implications of AI. My criticism of FATE is that it is overly focused on potential doomsday problems and risks with AI, and it doesn't make a fair-to-fair benchmark comparison against existing human processes. So when we look at ethical AI, and we'll go into more depth on that later, all of the terminology, all of the language, and all of the concerns people have over ethics in AI come from centuries of manual human processes that are horrible, right? AI did not invent racism and discrimination and bias. People did. And people inherently and implicitly have their biases and their issues, and that is definitely not transparent. And most of the metrics that we use for AI are learned from how we're trying to get at hidden biases in humans. And so I would argue that AI has not increased ethical concerns and issues. It's just made the existing human ethical concerns and issues more visible and transparent. So I don't believe that fate is a particularly good approach for managing ethical implications of AI, nor is it for managing an AI development project. Lean AI puts the emphasis on last mile of the AI production chain and how do you make it efficient and how do you scale it. And there's a lot of great things to learn in that. But again, I don't think it's holistic. The ROAD framework was developed by myself when I was at Accenture. And the advantages of the ROAD are that it provides an acronym that's easy to remember. So I find that like a lot of the steps, when you have CRISP-DM, the CRISP doesn't mean anything. It doesn't have anything to hold on to the steps. Whereas having a simple acronym allowed people to keep those steps in their mind, and I found that teams were more likely to adhere to it with that acronym. It also has a clear division of labor where you understand that there's not just an AI expert person, right? There are multiple roles, just like there's nobody that's an expert in all areas of medicine. You have specialists that specialize in certain areas. I wouldn't want to go to an allergist for knee surgery, right? I want to go to an orthopedic surgeon. So understanding how you have clear division of labor and where they fit into that framework and how they work together is encompassed by the ROAD framework. That also allows for greater accountability. And the most important thing is that it improves management outcome expectations. So you have a clear understanding of what the goal and outcome of the project is before you begin. This limits rework and it lowers your cost and time to develop success. The ROAD framework has 4 components. Requirements is the R, operationalized data is the O, analytic method is the A, and deployment is the D. The icon in the upper right is just showing that this is an iterative process as you're going through these different steps. So don't think of it necessarily as fully sequential, but there's a lot of little feedback loops that go throughout this process. The lower right is showing you the ideal team that you would use to deliver an AI project and how they fit into those projects. So the ideal AI team was actually initially developed by the Army for the Center for Army Analytics by a great colleague of mine, Sam Huddleston. And he did an assessment of different AI applications and software development. And he said, hey, this 4-person team is the ideal Army team for implementing AI and data science projects. Now, when I got to Accenture, we had a lot of industry input and trial and error there. And so I kind of blended that together, those two experiences together to create this team, which I used to call the Flash team, but you can put another spiffy name to it if you like. So the first role is the data scientist. The data scientist is usually the main effort in these teams. It's usually the senior person, the most educated and most experienced for most applications. Now you're going to change that if you are doing more of a data engineering task or software development task. But in a typical AI project, the data scientist is the AI lead for the team. And they are going to have the broadest understanding of the different algorithms and the different analytic methods that are going to go into the end case. So that's usually what I think of as the main effort. Now, context is important if we think back to the CRISP-DM, IBM methodology. So we want to have a domain expert, somebody that understands the business use cases and what will be useful to the business or the end client or the end customer at the end of the day. It's really important to have that input throughout the process working on that team. The other team member is the data engineer. The person that is good at storing and managing and manipulating data and moving data is often not the best person for understanding all of the algorithms and all the analytic methodologies that you may apply. The data engineer might be the same person that is the cloud architect, that is setting up the cloud environment or dealing with that aspect, because that's very much associated with that data engineering and data management. The visualization expert is the storyteller. That's the person that is, it could be, if you're doing a decision support type of outcome, it could be somebody that is showing, building the dashboards like your Tableau, your Qlik, your Power BI. So building those dashboards to inform decision makers. It could be the person that's writing the analytic report, if that's the deliverable. It could also be a software developer, a software engineer that is going to figure out how to build a software application or something that's going to automate it or integrate it into scale. It could be the cloud architect that is going to say, hey, how are we going to move this into a production system? Right? But the visualization expert, as I've listed here, is the person that is going to be in charge of that end deployment. And then you'll usually have a number of junior analysts or software developers supporting those various team members, those 4 team members. And so as you can see across the bottom of the slide, when we are scoping out requirements, this is where we understand the problem. We are decomposing the project or the task into its component elements to see where there might be gaps where AI can assist, help automate, or help improve. What decisions, what automation, what interaction type tasks would benefit the end use case or the business, right? This is led by the domain expert that is going to probably have additional training in how to facilitate that, how to do stakeholder identification and stakeholder requirement solicitation. Design thinking kind of fits into this if you've run across that. And that all falls on the purview of the domain expert. And all other team members are supporting the design expert's scoping of the requirements. Once we have some requirements, we're next going to do this operationalized data, where this is about collecting, storing, moving the data. Data is rarely, the data that you have on hand was probably not acquired for the purpose you're going to use it for now. So you are fundamentally doing something new with the data. How do you explore it? How do you transform it? How do you make it consistent? How do you take data from 2 different systems and pull them together? And this idea of operationalizing data is the idea that it's more than just getting the data together. It's convincing the decision maker, the end client, that they believe in the data, that it's a viable proxy for whatever their problem is. When we get to the analytic method, usually when you have a requirement and data type, the analytic methods are kind of, there's a right and wrong analytic method to use, right? But analytic methods is not just about algorithm and method selection, it's about the model training and parameterization. It's about assessing potential bias. It's about verifying and validating results. It's about interpreting the results, making sure they make sense. That's led by the data scientist. And then the last step is, how are we going to design the output? How are we going to visualize this? How are we going to build the automation? Are we going to monitor this for drift? And are we going to do model retraining? Or what are we doing in deployment that we need to consider? And so what this does is it fixes accountability to a role that has a different skill set and different labor makeup. And we'll talk more about different types of labor later in the course. And it has clear considerations that you have to do when managing an AI process. And in this way, what I have found in industry is it significantly reduces the cost to deliver and allows us to either increase our profit margin in tasks or have a better price to win in firm fixed price projects. In subsequent videos, we're going to go into more detail in each of these 4 steps, but this provides a general overview of the ROAD or ROAD framework. It's the one I recommend for use in managing AI and data science projects.